In this video, I'm going to show students how to divide fractions using the rule for dividing fractions and then thinking of their problem as a complex fraction. The rule for dividing fractions says that we keep the first fraction the same, we change the division to multiplication, and then we take the second fraction and we write the reciprocal of it. And the reciprocal is just switching positions between the numerator and denominator. Once you restate it as a mathematical expression, using the rule, you go back to your rules for multiplying, where you multiply numerator times numerator and denominator times denominator. 7 times 3 is 21. 8 times 2 is 16. Being that 21/16 is an improper fraction, students go to the side and say 16 into 21, and it will divide it one time with 5 left over. So now that it's improper, their answer becomes 1 and 5/16, which would be a mixed number. This is if you have two proper fractions. If a student had 10 divided by 9/11ths. The one thing students have to remember is anytime they're working a division problem and they have whole numbers, they need to restate them as a fraction by placing them over 1. Change it to multiplication and reciprocate the second fraction. Go back to the rule for multiplying. 10 times 11 divided by 9. That gives them 110 over 9, which it's improper because the numerator is larger than the denominator. So they divide. 9 will divide 11 one time with 2 left over. 9 will divide 20 two times with 2 left over. So their mixed number is going to be 12 and 2/9. If they're working with a mixed number, if they were to have -2 and 1/3 divided by 6/15, when they have a mixed number, students must remember to do the backwards C method, where they multiply 3 times 2, they ignore the negative and add 1 and place it over 3. So 3 times 2 is 6 plus 1 is 7, and that becomes 7 over 3, and you place the negative in the numerator. Then you go back to your rule for dividing, you change it to multiplication, and you reciprocate the second fraction. I've been teaching students to cross-reduce. To cross-reduce, students would look diagonally at 3 and 15. 3 will divide 3 one time. 15 divided by 3 is 5. By teaching students to cross-reduce, it eliminates having a larger product in their answer. So they have -7 times 5 over 1 times 6, which gives them -35 over 6, which is still improper, but it's a smaller number for them to work with. 6 will divide 35 5 times with 5 left over. So then their mixed number becomes 5 and 5/6, and they place their negative in front of their whole number. Where students get confused is if they have a mixed number divided by a mixed number. They tend to forget to reciprocate the second fraction. So before they work it, they need to do the backwards C, 5 times 3 plus 4, and divide it by 5. Then they're going to do the backwards C here, 3 times 1 plus 1, and place it over 3. So now their problem becomes 19 over 5 divided by 4 over 3. So now they're working with two improper fractions. So they would say 19 over 5, change it to multiplication, and reciprocate the second fraction. We refer to this as keep, change, flip for students to remember the rule of multiply by the reciprocal. 19 times 3 is 57 over 20. 20 will divide 57 2 times with 17 left over. So their mixed number becomes 2 and 17/20. I have showed students what a complex fraction is, because we will start working with ratios and rates and unit rates, and when we get into those, they're going to expect students to know what a complex fraction is. A complex fraction is a fraction where they could see a fraction in the numerator or a fraction in the denominator or in both of them. So a complex fraction would look something like this: 3/4 divided by 7/8. So it looks complex because we're not used to seeing the big fraction listed with a fraction on top of a fraction. Here they have a proper divided by a proper. Then if I gave them 5, which is a whole number, divided by 9/10, they read the main bar in the middle that I'm placing the arrows on. That is their main division bar. So I told the students to put the arrows on it to indicate that that was their main division. They could see something like 3 1/2 divided by 4/5. So this method, with it having a complex fraction, we use a different rule that's called our product of the extremes over the product of the means. So let's look at an example and see how we would go about solving this. Let's just take 4/5, and I'm going to make it a negative 4/5 divided by 6/7. So in order to work the problem when it's at a proper fraction, students need to remember that the extremes is the very top number and the very bottom number in the fraction, the complex fraction. So these are my extremes. So I'm going to say negative 4 times 7 divided by, and my means are the two numbers in the middle. So that would be 5 times 6. Okay, then you go back to your rule for dividing. If I cross reduce here, I know that 4 and 6 are both even, so I divide by 2, and that would give me 2. Divide 6 by 2, and that would give me 3. So now when I multiply, I have negative 2 times 7 divided by 5 times 3, which results in negative 14 over 15. Again, your rule for integers, if one is negative, one is positive, I'm unhappy, and my answer is negative. is how I am teaching students to remember the rule. Again, if it's a mixed number, 7 1/4, and I want to divide it by 2/3, I'm going to make it negative 2/3. If they're working with a complex fraction, their rule for mixed numbers still remains the same. Use the backwards C. So you have 4 times 7 plus the 1 would give you 29 over 4 divided by negative 2 over 3. Remember, the extremes are the very top and the very bottom numbers. So I'm going to multiply those together. That gives me 29 times 3 divided by 4 times negative 2. I can't cross-reduce these because none of them have common factors. So my means were the 2 in the middle. 29 times 3 is going to result in 87 over negative 8. It's an improper, so students would need to go to the side. 8 into 87, one time. 7 left over, we'll divide 0. So my mixed number is going to be 10 7/8, and it's going to be negative because 87 is positive, 8 is negative, and they're different signs. So when they're different signs, I have a positive and a negative, I'm unhappy, and my answer is negative. So that would result in my final answer.